Every pilot enjoys films of aircraft, and these planes should be of more than routine interest. Of course, many of you have seen these particular aircraft on your radar screens, or through your canopy, not just on a motion picture screen. Truly, there is quite a varied inventory of Soviet military aircraft, some frankly sort of slow and lumbering, others anything but. The important thing is that the Soviet Air Force is part of your real-world environment, and their various design bureaus, Mikoyan, Tupolev, Sukhoi, have turned out 21 different fighters in the past 15 years, 8 of which are now operational. And if you are going to preserve your air superiority against this varied arsenal, you need a real-world, threat-duplicating, superior target. This film introduces the new Air Force BQM-34F, a target designed to do just that. The name Firebee is hardly new to you pilots. In fact, the family line started 25 years ago with the XQ-2, sired by the Air Force. The intervening quarter century has seen more than 20,000 flights, almost a dozen growth versions of the classic bird. But only one has been different enough to be called Firebee 2. This one, the supersonic one. You can see how the 34F evolved naturally from the 34A. Longer and cleaner for supersonic flight, even on the deck. Here's the specific speed-altitude envelope of Firebee 2. Altitudes of more than 50,000 feet. Speeds of almost Mach 1.7. This overlay is representative of the speed and altitude capability of typical operational Soviet aircraft. The 34F covers the significant area of potential air superiority engagements. And within this performance envelope, it performs as well as anybody's fighter. Firebee 2 can pull 5G turns, almost 80-degree banks. It can do a 180 in just over 1 nautical mile at Mach 0.95. It is truly a demanding aerial target that will challenge the skills of any pilot. The rationale behind this emphasis on speed, altitude, and maneuverability is obvious to all of you. These are the variables you live by, literally. Here in simplified form might be today's typical real-world aerial encounter. 2 aircraft approaching at supersonic speeds using long standoff distance radar weapons at high altitudes. Then a drop in both speed and altitude for a re-attack with IR weapons, where the emphasis is on subsonic maneuvering. To duplicate this environment takes a target that can combine these varied flight regimes in a single training mission. A target with both performance and control. And the controller on the ground wants to know the same things about the 34F that you do about your aircraft. So 12 key data items are telemetered and displayed for his use. 26 remote uplink control commands enable him to present an elusive, variable speed target with various modes of augmentation. Here are the antenna locations. X-band, receive and transmit for both nose and tail radar augmentation. The L-band command-receiver antenna in the tail. An S-band beacon. And the low-altitude radar altimeter transmitter and receiver, which provides for true 50-foot minimum altitude flight. This is one possible mission profile. A combination subsonic cruise supersonic dash mission. A climb and cruise to about 45,000 feet with almost half an hour of Mach 0.9 maneuvering flight. Then a jettison of the external tank a quick supersonic climb to over 50,000 feet, and 20 minutes more of additional flight at Mach 1.5. The low-altitude profiles are equally dramatic. Here's a 22-minute mission starting at 500 feet, ending with a supersonic dash 50 feet off the deck. Between these two mission extremes, there are an infinite number of variations. Firebee-2 can fly the way your particular threat aircraft would perform. But aerodynamic performance is only part of any drone story. To duplicate a broad spectrum of threat aircraft demands augmentation, and quite a variety of it. How about a look at IR augmentation? This is the approximate IR dispersion pattern of the MiG-21. For obvious security reasons, we have deleted the specific watts per steradian. This is the pattern of the 34F IR source. Again, we are comparing patterns only, with no attempt to scale the drawings to each other, but the similarities are obvious. This pattern allows front quadrant and beam intercepts in addition to standard stern pursuit. This profile is familiar to all of you, the MiG-21. In size, the Firebee-2 does not seem like a very realistic simulation. But let's look at radar cross-sections, the size that really counts in today's electronic environment. This radar cross-section polar plot is skin only on the Firebee-2. We'll add the tail and beam augmentation that is available from the TWT and its waveguide installation. Now let's make the comparison with the MiG-21. The composite augmented cross-section is surprisingly close. It was designed to be. This radar cross-section augmentation can be varied greatly to simulate virtually any threat aircraft. Plus or minus 70 degrees in both azimuth and elevation, and the patterns are switchable in flight from one side to the other. But is Firebee-2 radar simulation really operationally realistic? Lieutenant Commander Lefebvre, F-4J radar officer with extensive Southeast Asia combat experience, said, "I was surprised at the radar image it offered. It was much bigger than I had expected." Lieutenant Commander Holstein, F-4J pilot, said, "Best simulation of an enemy threat." Why an endorsement by Navy pilots in an Air Force film? They were the first men to make a Firebee-2 operational kill. It was a head-on presentation, 30,000 feet, Mach 1.23, a hit with a single Sparrow missile at the Pacific Missile Range, mid-August 1972. To return a moment to the actual sizes, the thin, sleek shape of Firebee-2 offers an important training advantage. It is realistic on the scope, but survivable in the air. Let's face it, scoring is the game, not destroying the bird. And there are two scoring systems available on the 34F. The MAT system, with its transmitter, antenna, and surface station, which locate the attack missile by triangulation. And the Digitop scoring system, co-located on the wingtip with either target augmentation source, IR or X-band radar. For example, here at Tyndall, the Air Defense Weapons Center, every missile that is launched is scored, and the results compiled in a data bank. Combat Echo and Combat Sage weapon system evaluation programs have the same requirement. And the Air Force knows better than anyone else how survivable Firebee drones are. ADC holds the record, 77 flights, and still flying on this one bird. It's hard to envision a more cost-effective target. The record number of flights so far on a single Navy Firebee-2 is 10, and that over a 20-month period of time. So whether the 34A or F, they both have the same prudent design emphasis on reuse, the same high degree of cost-effectiveness. The Air Force is utilizing the mid-air retrieval system for 34F retrieval with great success. When the engagement chute is captured by the helicopter grapple hooks, the main parachute disconnects and drops from the drone. The drone is winched into an optimum slung load position and returned to base with no recovery damage. This Mars recovery technique permits faster, more economical turnaround than a water recovery. One of the nicest things about Firebee 2 is that it is here today, not years away. Flight test has been completed by the 65 14th Test Squadron at Edwards, and the drones are now in Air Force inventory, available for routine operational use, like any other drone. So the next time your squadron deploys for training or weapon system evaluation, whether you fly the F-4, F-101, F-102, F-106, or even the F-15, you will find Firebee 2 ready for your training missions. It is definitely not a docile, predictable drone, but a fast, maneuverable aerial target that can simulate the threats your particular missions require. Firebee 2, a real-world simulating drone, one that flies smart like another pilot.